more practice graphing rational functions. So I'm going to go through these fairly quickly. These are just some extra examples that I did, and I'm not going to go through graphing them on the calculator. Leave that for you to do. I'm just going to graph them based on what I find. So this first example is 2x minus 1 over x. There's nothing to factor, so this is as simplified as it gets. Its domain, well, you can't have 0, right? The division by 0 will give me out 0. And there's no way to get rid of it. The x's don't cancel, and so there's no hole in the graph. I do have a vertical asymptote then at x equals 0. Or better known as the y-axis. And I'll indicate that by drawing the x equals 0. Alright, my y-intercept, well, there isn't one, right? There is no y-intercept because x cannot be 0. I do have an x-intercept. When I plug in 0 for the function, right, 0 for y, I set the function equal to 0. Remember, the only 0 I can have is in the numerator. So 2x minus 1 will give me out a 0, so x equals 1/2. So my x-intercept is at 1/2, 0. So a vertical asymptote at x equals 0. I have an intercept, x-intercept only, no y-intercept, and then my end behavior. Well, if you look at it, the degrees are the same, right? Degree of 1 in the numerator, degree of 1 in the denominator. The leading coefficient is a 2 divided by a 1. And so I do have a horizontal asymptote at y equals 2. Alright, so really there's only 3 things that I have, 3 pieces, but I'll use those 3 pieces to graph it. And then you can check on the calculator that it is the shape that I'm going to give you here. First thing is, I know that x equals 0, which is my y-axis, is an asymptote. Alright, so I know my graph should approach on either side of the 0. It should approach an infinity or a negative infinity, right? That's my vertical asymptote. Then it has a horizontal asymptote at y equals 2. So there's y equals 2, and so it should approaches it at the tail. And then I have an intercept at 1/2, 0, so that puts me here. Alright, then I know the nature of the graph. That's the only place it crosses the x-axis. And I have to approach my asymptotes at the tails. And so I know that since it's crossing the x-axis, and that's the only place it's crossing the x-axis, it's got to come up here and approach my asymptote on that side, and then it's got to come down here and approach my asymptote on that side. And so the shape of this graph is this little piece on this side. It's approaching my y-axis, shooting down to negative infinity, and then it's approaching my horizontal axis at 2, which tells me, since it doesn't cross the x-axis over here, the graph has got to be above my asymptote, because it can't cross it, because it's got to both approach my asymptotes, alright? So it's got to be above here, because I know it doesn't cross the x-axis, I know it doesn't cross the y-axis, and it should approach both the y-axis and the line y equals 2, and so the only possibility is for the shape to be up there. And there's the graph, and I'll leave it for you to check. If you graphed this function on your calculator, that is what your graph should look like. It should cross at that one moment. Alright, next example. So again, I'm going to go through these really fast since we've already done a bunch of them. So the next example, I can factor this one a little bit. Up top factors into x minus 2, x plus 1, all over x minus 1, and so there is no common factor. Domain x cannot be 1, right? No common factors, no holes in the graph, and so that means I do have a vertical asymptote. Vertical asymptote at x equals 1. Alright, I have a y-intercept. If I plug in 0 for x, 0, 0, 0, and so it comes out negative 2 over negative 1, so it comes out positive 2. So 0, 2 is my y-intercept. I have x-intercepts as well. Remember, it's where y equals 0, the function equals 0. I can only have 0 in the numerator, so x minus 2 and x plus 1. And so I have two x-intercepts at 2 and negative 1. So at 2, 0 and negative 1, 0. Alright, so there are my x-intercepts. End behavior. Well, the degree in the numerator is bigger than the degree in the denominator, and so this is a slant asymptote case. Means my tails are shooting off to infinity, but they're shooting off to infinity in such a way they should be approaching a slant asymptote. Alright, so I have to find the slant asymptote, which means I have to do division. And so I'm going to divide this out. My k is 1 in this case, so it's 1. And then it's 1, negative 1, negative 2, 1, negative 1, negative 2. Divide it out, drop my 1. Alright, well actually, so again, it doesn't matter that that is my rational function. My quotient is just x. It would be x plus 0, but we don't write down x plus 0. So my quotient is just y equals. So the line y, it's the nice line that goes through my origin. Alright, that's my slant asymptote. Alright, the line y equals x. Alright, there's all the pieces of information that I need to graph it, so I'm going to graph it here. And so, first I'll start with that slant asymptote. The slant asymptote goes through 0, 0, and then it goes through 1, 1, negative 1, 1. So again, it's that line that goes through. All of my values are the same. Didn't really draw a dress there, but there's my y equals 0, my slant asymptote. Alright, then I have a horizontal, or sorry, no horizontal, vertical asymptote at x equals 1. So right here, at x equals 1. My dotted lines are getting a little solid. So x equals 1 is my vertical asymptote. There is no hole in the graph, so now I've got a bunch of points though. I've got 3 intercepts, 0, 2. So 0, 2 puts me there. 2, 0 puts me here. And at negative 1, 0. Alright, so that's 2, 0, 0, 2, negative 1, 0. Which again, that's all. I have enough information to graph my line. And I'll leave you could check it. So graph it on your calculator and check my answer. But I know the vertical asymptote and the slant asymptotes, you can't cross them. So my tails of my graph should be approaching them. And so since I have points on both sides, I'm good to go. I have to go through this point, and then it's going to come up here and approach that asymptote. Go through this point. It's going to come down here. A little too much. Come down here and approach this asymptote. And then the same thing over here. I know I go through both of those intercepts. It's going to go through both of them and then approach my asymptote on that side and approach my asymptote on that side. And there's the graph of my function. Which again, I'm going to leave you to check the graph on your calculator, but the graphing calculator should look like that once it comes out. Alright, I've got one more to do, and actually I didn't leave myself a lot of room, so I'm going to rewrite it down here. So the last one was x plus 2 over x squared plus 4. Oh, not plus 4, minus 4. And so that does factor into x plus 2 over x minus 2, x plus 2. And so I do have a common factor in this case. Alright, so first the domain though. Domain, x cannot equal 2 and negative 2. Doesn't exist at 2 and doesn't exist at negative. So there are breaks in the graph at 2 and negative 2. Does not exist. And so one break is asymptotic and one break has a hole in the graph, right? I have a common function, common factor of x plus 2, which means there is a hole at x equals negative 2. I have to reduce to find what the y value is. Reduce, and so the reduced function would be, this simplifies when I reduce it to 1, right? X plus 2, not x minus 2. It's easier to do that. X plus 2 divided by x plus 2 is not 0, it's 1. So you have to remember there's an understood 1 left over. And then I'm left the x minus 2 in the bottom. Right, so that's what it reduces to, 1 over x minus 2. And so when I plug my negative 2 in, so my y value is g of negative 2, the reduced. So I get 1 over negative 2 minus 2. And so 1 over negative 4. And so I have a hole at negative 2, negative 1/4. And I've got to remember that's an open point when I go to graph it. Alright, and then I also have a vertical asymptote, the other break. So I have a break at negative 2 is a hole. I have a break at positive 2. There's no way to get rid of that break, so I have a vertical asymptote at positive 2. So I've got to remember at x equals -2, there should be an asymptotic behavior break there where I'm approaching it infinity and negative infinity to the left or the right. All right, my intercepts. All right, there is no x-intercept because there's no, if I try to plug in, if I try to set this equal to 0, it doesn't exist at -2, right? So if I look at the reduced form, there's no way to let 1 equal 0, right? You can't magically change 1 to 0, and so there is no x-intercept. All right, there is a y-intercept when I plug x equals 0 in. So g of 0 comes out -1/2, so 0, -1/2. All right, so that's it. No x-intercept, there is a y-intercept. All right, then the last thing is my end behavior, right? End behavior, which I look at my degree. So if you go back to the original function, the degree of the numerator is less than the degree of the denominator. So this is the approaching 0 case, right? My function, if I plug in bigger and bigger values, fractions get smaller and smaller. And so the end behavior is I have a horizontal asymptote. At y equals 0, or better known as the x-axis. All right, so now putting it all together. All right, so first of all, it's going to approach my y equals 0 on both tails, right, as x goes to infinity and negative infinity. All right, the other asymptote is at x equals 2, so 2. So there's x equals 2, and then the hole in my graph, so I don't forget it, there's a hole in the graph at -2, -1/4, so -2. -1/4 isn't very big, so it'd be really close to the axes there. That's the open point, -2, -1/4. Alright, then it has a no x-intercept, but it has a y-intercept at 0, -1/2, so again that puts me 0, -1/2 puts me there. And that's all the information I have, right? I've got my hole, my asymptote, okay. Alright, so based on this, I can still graph it, and you'll check it on the calculator. I know that I'm on this side, right? Because I go through my 0, -2, so I've got to approach my asymptote here, so it comes down. It approaches the hole, and then after it, it's going to approach my negative. It's going to approach the y equals 0 that shoots off to negative infinity. Based on that, I don't have another point over here, but when you graph it, you should see the behavior is it should flip over and be on the other side. You could always check it by picking a number over here. If I picked a number over here, it should be graphed above. So it should be above. It should, because it doesn't cross my x-axis anywhere. It should approach my asymptote on this side. And when you go to graph it, this is what the graph is going to look like. So when you check my answer, all right, graph it out. This is what the graph of this particular function should look like. All right, so that finishes up. And so like I said, this was just some extra examples that I went through fairly quickly. And hopefully you followed along.